The teaching at Vedantu was amazing. One aspect where Vedantu teaching differed from a normal offline coaching was the attention teachers gave to our doubts. No matter how many times we asked a doubt, the teachers would patiently clear the doubt every single time. And they made learning a very fantastic experience for us.
Hi guys, how are you? क्या हाल चाल है? This is Saurav Goswami here on the Vedantu channel, and again I have come in front of you with this amazing topic, electrochemistry, and this is the lecture 11 on electrochemistry. अभी तक हमने 10 lecture खत्म कर लिए हैं. Welcome everybody who is joining us today for this session, and in this session we would be talking about behavior of ions. We have already completed a lot of things. Nernst equation, cells, galvanic cells, voltaic cells, and this is where we would be talking about what is the behavior of ions within a solution. Okay, usually हम लोग करते क्या हैं कि we talk about we have already discussed about Faraday's law, and in Faraday's law we had discussed that when we pass electricity through a solution, it is the ions that move and ions dissociate. And because of that, a few observations are obtained. Some gases are obtained at certain electrodes into identifying that why it is happening. Okay, why it is happening. So let's start today's session, and this is the easy topic. Okay, ये electrochemistry का एक easy section है, and इसको हम share and subscribe the channel so that you are always updated with all the amazing content. Also, I'd like to tell you that we have already started with the KVPY SX and SA classes, and please take maximum benefit of these classes. Also, there would be a test series on KVPY which will include certain mock tests and certain full length tests, certain part tests. The pricing is very competitive, 1000 rupees. Please do seek the information in the comment section, and please do tell your friends. Please do involve as many friends of yours in that KPY test series. Okay, so yeah, you can also join. So what we have completed until now is Faraday's law, electrolysis cases. This is already covered, and the part of behavior of ions will be covered in this class. Okay, behavior of ions will be covered in this class. So behavior of ions के बाद बच जाता है conductance का part, जो कि हम लोग आज almost cover कर लेंगे, and Colruy's law, which is a very important law, and from this definitely 1 or 2 questions will come in every alternate year. Okay, so without wasting any time, let's start today's session, and आज के session में देखते हैं कि हम लोग करना क्या है. So we'll talk about electrical conductors, starting the topic with electrical conductors. So electrical conductors are of 2 types. आपने देखा होगा metallic conductors like copper wires, silver wires और gold के wire. These behave as electrical conductors, जो कि electrical wiring के लिए use होती है, वो हो जाता है electrical conductors. And what is the other type of conductor? It's a electrolytic conductor, the one which is present in a battery, the one which is present within our body. I'll talk about what kind of conductors present within our body. So metallic conductors, which is very easy, आपने physics में भी इसके बारे में पढ़ा होगा कि these conductors are the ones which will transport electricity due to the movement of electrons. Can you see this? Transfer electric current by transfer of electrons without transfer of any matter. It's not that the matter is getting transferred, the electrons are moving. Okay, so it is very important to know that the matter is not getting transferred, the electrons are moving, and that is causing the movement of electrical current. So metallic conductor has that property. When we talk about electrolytic conductors, then ions carry the current. Ions carry charge, and because charge is a function of current and time, so I can say conversely that it is the ions moving in the solution which are carrying current. So conductors like aqueous solution of acid, bases and salts behave as electrolytic conductors because they carry the current, and also it is involved, it is also simultaneously assisted with और ये साइमल्टेनियस प्रोसेस ये भी होता रहेगा कि डिकम्पोजिशन होता रहेगा सब्सटेंसेस का. दैट इज द रीजन Faraday's law was working. So when we pass electrical current through an electrolyte, decomposition of chemical substances will take place, ions will be produced, and these ions will carry the current. Okay. Now one very important idea about electrolytic conductors and that differentiates it from metallic conductor is that when you increase the temperature, the conduction increases. When you increase the temperature, the conduction increases. Metallic conductor के केस में क्या होता है? What happens in metallic conductor when you increase the temperature? When you increase the temperature, the conduction decreases. Have you seen that? When you increase the temperature, conductance decreases, and because आपकी resistance increase कर जाती. So in over here, increase in temperature, resistance decreases. Unlike metallic, इसमें decrease होना चाहिए था यहाँ पे, decreases unlike metallic. Okay, so this had to be decreases. Okay, this had to be decreases. Why it is decreasing? Okay, ये डिक्रीज क्यों करता है? इसलिए क्योंकि आयॉन्स बहुत रैपिडली मूव करते हैं. ओके, आयॉन्स बहुत रैपिडली मूव करते हैं. कंडक्टेंस इज रेसिप्रोकल ऑफ रेजिस्टेंस. यस, वेरी गुड. सो इस बात को ध्यान में रखो कि हमारे बॉडी में भी ये इलेक्ट्रिकल इम्पल्सेस का ट्रांसफर होता है अराउंड द नर्व एंडिंग्स. जो इलेक्ट्रिकल, लेट्स से यू टच समथिंग and you feel the sensation, that is because of the transport of a electrical impulse. Your body, okay, your body also generates a certain amount of current, and this current is being transported by the ions about the point of contact of neurons. And वहाँ पे आपने पढ़ा होगा बायोलॉजी में, if you have read, there is sodium potassium channels which are responsible for transfer of this thing. So if you are dehydrated, ions की concentration कम हो जाएगी, and what will happen that your electrical conductivity will be decreased and sensory stimulation कम हो जाता है. Basically, if you are dehydrated, you would not be able to perceive a lot of things with that clarity. आप बोलोगे कि कंसंट्रेशन मेरे को नहीं हो रहा है. अगर आपने खाना नहीं खाया तो आप बोलते हो कंसंट्रेशन मेरे को नहीं हो रहा है किसी चीज़ में, आई एम हैविंग अ हेडेक. व्हाई इज दिस हैपनिंग? बिकॉज द इलेक्ट्रिकल इम्पल्सेस आर नॉट गेटिंग ट्रांसपोर्टेड बैक एंड फोर्थ विद द सेम विगरोसिटी जो कि होना चाहिए था. मतलब उतना नहीं हो सकता है. ठीक है. सो विद दैट इन माइंड, लेट्स लुक एट द डिफरेंसेस बिटवीन द टू. इन दोनों के बीच का डिफरेंसेस क्या होता है? सो मेटेलिक कंडक्टर्स में फ्लो ऑफ इलेक्ट्रिसिटी टेक्स प्लेस विदाउट द decomposition of substance. In metallic conductor there is no decomposition of substance, while in electrical conductors there is decomposition. So decomposition होगा तभी ions बनेंगे, and तभी electrolytic conduction होना चाहिए, तभी electrolytic conduction होगा. Okay. Second point क्या है? Flow of electricity is due to the flow of electrons. Over here, flow of electricity is due to the flow of ions. If ions are moving, only then electrolytic conduction will take place. इसी की keeping that in mind, electrolytic conductors को हम लोग दो parts में divide कर देते हैं. One is a strong electrolyte and one is a weak electrolyte. एक weak electrolyte वो होता है which does not produce a lot of ions, like water, any alcohol, acetone. ये सारी चीज़ें पोलार तो हैं, but they will not produce good degree of ions upon dissociation. But if I take HCl, if I take H2SO4, if I take a solution of sodium chloride, if I take a solution of acetic acid, they will dissociate to a very large extent, and they will produce a lot of ions which will increase the conductivity. Okay, yeah, dissociated completely. If I have taken acetic acid, तो acetic acid कम dissociate करता है, but you can increase the dissociation of acetic acid. Acetic acid is at least, let's say I take aqueous solution of acetic acid and I take water mixed with alcohol. दोनों का अगर हम conductivity measure करते हैं, then the electrical current will travel faster through a solution of acetic acid in water. Vinegar के solution में ज़्यादा fast travel करेगा. Okay. Flow of electricity is due to flow of ions. Next, the conductance decreases with increase in temperature. देखिए, कंडक्टेंस जो है वो डिक्रीज कर जाती है क्योंकि रेजिस्टेंस इंक्रीज कर जाता है. इन मेटेलिक कंडक्शन, कंडक्शन डिक्रीजेस विथ इंक्रीज इन टेम्परेचर, बट इन इलेक्ट्रिकल और इलेक्ट्रोलाइटिक कंडक्टर the conductance increases with increase in temperature. Increases with increase in temperature. Why does it increase? Because when you increase the temperature, the kinetic energy of molecules increases and they will move faster. Okay, the kinetic energy will increase and they will move faster. ठीक है, so kinetic energy increase करेगी, इसलिए वो ज़्यादा जल्दी electrodes पे जाएंगे. Okay, so that is the reason, Shiv, that because we increase the temperature, kinetic energy increases, they move to the electrodes faster, and so conductance will increase. The last one is resistance. क्यों होता है metallic conductors में? In metallic conductors, resistance is because of vibrating kernels. ये physics में पढ़ते हो that it is because of vibrating kernels that metallic conductors have resistance. But in electrolytic conductance, the resistance is often due to interionic attraction. Suppose there is an ion and there is another ion and they are trying to move in the opposite direction. If the attractive force is large, the conductance will be less. Okay, if the attractive force is large, then the conductance will be less. Reason for metallic conductors, conductance, it's written over here. It's because of movement of free electrons. They have free electrons, they can move, and because of that, अब क्या physics में ये पढ़ोगे, there is something known as band theory, conduction band and valence band. So you will understand it in a greater detail that how metallic conductance takes place in case of physics. Okay. So they oppose the motion. If there are two ions, hello Kushal, so if there are two ions with opposite charge, एक opposite direction move करेंगे and because of that the resistance will come into play. तो हम resistance को decrease कैसे करें? I will add water. Water will act as a dielectric which will reduce the electric lines of force and it will facilitate faster movement of ions. So the resistance is offered due to interionic. So I have a question for you guys. If you take a concentrated solution of HCl and you take a dilute solution of HCl which will have a greater conductance. If you take a concentrated solution of HCl and if you take a dilute solution of HCl which will have a greater conductance, किसका conductance ज़्यादा होना चाहिए? Please tell me in this comment section. Dilute, very good. डाइल्यूट का कंडक्टेंस ज़्यादा होना चाहिए बिकॉज डाइल्यूट में आयॉन्स नज़दीक नहीं रहेंगे. व्हाट हैपेंस इन डाइल्यूट दैट आयॉन्स विल नॉट बी वेरी क्लोज. सो डाइल्यूट के केस में जो H+ आयॉन रहेगा और Cl- रहेगा उनके बीच में काफ़ी ज़्यादा डिस्टेंस रहेगा. देयर विल बी लॉट ऑफ डिस्टेंस बिटवीन द टू ऑफ देम. हाउएवर इफ आई टेक अ कॉन्सेंट्रेटेड वन देन दे वुड बी प्रेटी क्लोज टू ईच अदर. So when they are very close, the resistance is high because it has less number of solute. No, it's not because of less number of solute. The thing is, in a concentrated medium, the ions will be very close to each other because we have a lot of cation and anion. Concentrated का मतलब क्या है? आपके पास amount of solute is very large. So amount of solute being very large, the ions will be very close to each other and they will oppose the motion of each other. But if the amount of ions is less, amount of water is more, then the force of attraction that the ions can perceive is less and they can move freely. ठीक है? So concentrated का conductance कम रहता है, dilute का conductance ज़्यादा रहता है. We can also prove it with a mathematical equation. ठीक है? चलो, मैथमेटिकली हम कंडक्टेंस को मेजर कैसे करते हैं? हाउ डू वी मेजर कंडक्टेंस मैथमेटिकली? ओके, सो लेट्स लुक ओवर हियर. कंडक्टेंस इज अ प्रॉपर्टी ऑफ अ कंडक्टर व्हिच फैसिलिटेट्स द फ्लो ऑफ करंट. इट इज एक्सप्रेस्ड एज, इट इज वेरी गुड, very very good. The conductance is a property of a conductor which facilitates the flow of current. It is expressed as the reciprocal of resistance. Let's work it out. Let's try to identify the expression for this. Now you know R, which is resistance, R जो हम resistance को बोलते हैं, R is equal to rho L upon A. I guess you know this expression from physics. Resistance is equal to resistivity times length of the conductor by area, isn't it? Now in case of electrolytic conductors, what is the meaning of length? What is the meaning of length? वायर के केस में तुम बोल सकते हैं वायर का लेंथ ले लिया, वायर का क्रॉस सेक्शन ले लिया, आई कैन कैलकुलेट द लेंथ एंड एरिया. बट इन अ सॉल्यूशन हाउ व्हाट इज द मीनिंग ऑफ लेंथ? तो इसको समझने के लिए लेट्स अंडरस्टैंड इट इन दिस वे दैट देयर इज अ जार. ओके, देयर इज अ जार. There is a jar which is having a metallic plate. One of the faces is converted into a metallic plate. ये एक metallic plate है, ठीक है? This is a metallic plate, and the other side is also a metallic plate. Okay, this is also a metallic plate. So assume that rather than taking a complete glass jar and complete glass jar, you have taken a glass jar made in such a manner that two opposite faces are made up of some conductor like platinum आपने ले लिया. Okay, and इनके बीच में एक solution present है. Okay, there is a solution present over here. इनके बीच में solution present है. Solution is present in between them. Clear? Now I connect them, these plates, with a battery. I have connected these plates with a battery. Clear? What will happen? This will acquire a positive polarity, this will acquire a negative polarity, and there is a solution. Now what do we understand from this arrangement is that this distance is the length that we are talking about. Okay, ये जो length आप ले रहे हो rho L upon A, this is the distance between the conductors. Okay, ये जो plates के बीच का distance है, that is taken as L. Okay, that is taken as L. The distance between the plates is taken as L, and the cross-sectional area of the plate is taken as A. Okay, the cross-sectional area of the plate is taken as A. So it is written over here for conductance measurements of a solution, L represents the distance between the electrodes or the plates, and A represents the area of the electrodes or the plate. Okay, clear? Now it is important to know that this is the expression that we would be using. Suppose हम reciprocal लेते हैं, what will happen? Okay, I hope this is clear. So I take the reciprocal of this. So 1 by R will become 1 by rho times A upon L. Okay, 1 by R. If I use this expression 1 by R is known as conductance, which is expressed as G. 1 by R is expressed as G. Clear? 1 by R is expressed as G, which is conductance. 1 by rho is expressed as K, which is conductivity. और A और L तो वैसे ही रह जाएंगे. So this becomes your conductance, and this is your conductivity. Conductivity, ठीक है? K को आप कप्पा भी बोलते हैं, इट्स अ ग्रीक अल्फाबेट, कप्पा बोलते हैं. What is the unit? Let me raise this. So G will have a unit of ohm inverse, or G will have a unit of ohm inverse, or S, which is known as Siemens. Okay, G is known as ohm inverse or Siemens. Clear? What will be the unit of kappa? What will be the unit of kappa? G is Siemens or ohm inverse. So I will write it as, यहाँ पे क्या बचेगा? Centimeter. So ohm inverse centimeter inverse. Can I write ohm inverse centimeter inverse? The units are very important because you might feel that कि कितना easy topic है, but JEE में जब question आएगा then it will become very challenging. So remember कि किसी भी तरह से question आपको पूछा जा सकता है. So it will be, this will be centimeter, A is in centimeter square, this is in centimeters, so this will become ohm inverse centimeter inverse, or Siemens plus Siemens centimeter inverse. Siemens centimeter inverse, ये आपका units हो जाएगा. Clear? Conductivity is the resistance. How do I express conductivity? Conductivity को कैसे express करेंगे? तो conductivity will be written as G times L upon A. ये लिखा जा सकता है G times L upon A, or if I multiply this with L and divide it with L, if I multiply this with L and divide it with L, it is nothing but L square by volume. L square by volume. So इसका मतलब ये हो गया कि G is nothing but equal to kappa times volume. Okay, G is nothing but kappa times volume. If the length is 1 centimeter, if length is 1 centimeter, so इसको यहाँ पे 1 आ जाएगा and G will become this. So can I say that the conductivity is nothing but the conductance for 1 centimeter cube of a conductor? Okay, kappa is conductance for 1 centimeter cube of a conductor. Please do remember this relation because इस relation के ऊपर question directly पूछे जाते हैं. One another important thing. When I would write something like this, इससे और एक inference हम निकाल सकते हैं. I can make out one another inference. Kappa can be written as G times L upon A. This L upon A is expressed as G star. This L upon A is expressed as G star. G star is known as the cell constant. बहुत सारे questions में you will see that the cell constant of this cell is given. From there you calculate conductivity, conductance, and so on and so forth. A lot of associated information. This is cell constant. Okay, so kappa is equal to conductance times cell constant. Clear? If this relation is clear, so you have to be thorough with this, and this relation. Okay, if this relations are thorough, let's move on to the next thing. Next चीज जो है वो हम बात करेंगे मोलार कंडक्टेंस एंड इक्विवेलेंट कंडक्टेंस के बारे में. ओके, सो मोलार कंडक्टेंस होता क्या है? बहुत सिंपल डेफिनेशन है. देखिए, साइन डिफरेंट है, द साइन इज डिफरेंट बट इट इज एक्चुअली कंडक्टेंस कैलकुलेशन. ओके, this is actually conductance calculation. So molar conductance and equivalent conductance, whatever you are seeing, I am not using the sign G, I am using lambda. But even though the sign is different, don't worry, this is the same as measurement of conductance. Okay, how do we measure both of them? So molar conductance is the conductance of a solution containing 1 mole of an electrolyte. It is the conductance of a solution of 1 mole of electrolyte. Assume that you are provided with a solution of M molarity. Okay, if a solution's concentration is M molar, if the solution's concentration is m molar, can I say that m moles are present in 1 liter? बोला जा सकता है ना, ये तो मोलारिटी का डेफिनेशन होता है. ओके, this is the definition of molarity. Molarity's definition is number of moles by volume in liter. So if I say that the molarity is 5 molar, that means can I say that 5 moles is present in 1 liter? That is the simplest way I can explain this. I can also say it in a very different way. हम volume change करते रहेंगे तो moles भी change करता रहेगा. However, this is the most simple way I can express. If molarity is m, that means m moles is present in 1 liter. Clear? So अगर m moles 1 लीटर में प्रेजेंट है, क्या हम बोल सकते हैं कि m moles are present in 1000 centimeter cube, 1000 cc, 1000 ml में प्रेजेंट है. ओके, सो m moles 1000 cc में प्रेजेंट है, तो 1 mole is present in how much volume? Is present in how much volume? कितने वॉल्यूम में प्रेजेंट रहेगा? 1000 अपॉन m ml, 1000 अपॉन m ml. ओके, इज दैट अंडरस्टूड? ठीक है. सो इफ दिस इज अंडरस्टूड, हाउ डू वी adjust it in the equation? I had earlier written that conductance is equal to K times volume. I had earlier written as conductance as K times volume. जब conductance को हम K times volume लिखते हैं, and if it is molar conductance, इसका sign change हो जाएगा. I will write it as lambda m. If it is calculated for molar if it is calculated as molar conductance, तो हम G को बस lambda m के जैसा लिख देंगे, K हो ऐसे ही रह जाएगा. And what is the volume? What volume contains 1 mole of electrolyte, which is I have calculated over here. This will be 1000 upon V. So this is 1000 upon m. So this is the expression that I have to work with. 1000 upon m is the volume which will have a certain molar conductance. ठीक है? So इस expression को हमने use करना है. Similarly, if I calculate equivalent conductance, तो expression में बहुत ज़्यादा difference नहीं है. Rather than writing molar conductance, I will write equivalent conductance, which will be equal to kappa times 1000 by, I can write E, which is C, where C is in terms of normality. Okay, C is in term of normality. What is the meaning of equivalent? और equivalence हम कहाँ measure करते हैं? When we take a normal solution, normality लेते हैं. If I say that I have taken 5 normal solution means 5 equivalents in 1 liter. 5 equivalents in 1 liter or 1 equivalent in 1 upon 5 liter. This is what the expression will turn out to be. So 5 is nothing but the normality. So this expression can be further rewritten as 1000 upon n. बस इस तरह से I will have to write it like this. This is EQ. Okay, what is the relation between molar conductance and equivalent conductance? Because many times in JEE, in integer type questions is asked they'll be giving a solution जिसका मोलार कंडक्टेंस दे देंगे, आपको उसका इक्विवेलेंट कंडक्टेंस कैलकुलेट करना बोला जाएगा. So the method is very simple. Molarity, or I can say normality, is equal to molarity times n factor. ये रिलेशन होता है. Molarity times n factor turns out to be normality. Molarity times n factor is normality. So हम normality के जगह पे molarity times n factor लिख देते हैं. So I can write lambda eq is equal to kappa times 1000 by m times n, m times n. This part is nothing but molar conductance. So this can be write equivalent conductance is equal to molar conductance by n, which will give me molar conductance is equal to equivalent conductance times n. Okay, molar conductance is equal to equivalent conductance times n. So this is the final relation. The relation between molar conductance and equivalent conductance is molar conductance is equal to equivalent conductance times n. Don't make a mistake. A lot of people make a mistake because they use this equation. इस equation में क्या है? Normality is equal to molarity times n. लेकिन molar conductance is equal to equivalent conductance times n. Okay? This is very very vital. इसको याद रखिए. And with this, we'll move on to the next thing where we will solve some problems. So if you have a pen and a paper ready with you, please solve the first question. First question क्या है? The conductivity of 0.2 m solution of KCl is 0.0248 Siemens per centimeter. Calculate molar conductance. Calculate molar conductance. Molar conductance हमें calculate करना है. So I'm giving you some time. Please try to solve the question. So molar conductance का question है. देखिए इसमें क्या क्या information दिया गया है. You have been given the molarity. You have been given the value of conductivity. So how do you calculate molar conductance? Try to solve this. Try to solve this. Okay. So guys, if you solve this, it will be easy. मतलब आपको समझ में आ जाएगा. Your understanding will be cemented. So how do we solve this question? I will use this expression molar conductance is equal to kappa times 1000 by m. Kappa time. So answer is 0.8. Okay, it is 8. Let's see if it is 0.8 or something else. So molar conductance हमें calculate करना है. कप्पा की वैल्यू क्या दी गई है? 0.0248 times 1000 upon 0.2. Okay, I'll get this. So just cancel out this and this will get cancelled, and you will have 1 2 4 1 2 4. What will be the unit of molar conductance? What will be the unit of molar conductance? क्या होगा unit बताइए? What will be the unit of molar conductance? Siemens centimeter inverse mole inverse. 124 Siemens centimeter inverse mole inverse. This can also be written as 124 ohm inverse Cm inverse mole inverse. ठीक है? Clear? So lovely. So let's move on to the next question. Next question is this: the resistance of a conductivity cell containing 0.001 molar KCl solution is 1500 ohm. 1500 ohm. What is the cell constant? You have to calculate what is the cell constant if conductivity of the same concentration of solution is 0.146 times 10 raised to minus 3 Siemens per centimeter. You have to calculate cell constant. See, question किसी भी form में आ सकता है. It might look like the information given is a little tedious, a little repetitive, but remember, every good student has to take the information whatsoever is coming and replicate them into workable methods of solving problems. Okay, so what is the answer to this question? बताइए क्या होगा answer? Rimfest facts, we need to calculate, yes, we need to calculate L by A. So what is the answer? Yeah, I understand, length by area आपको calculate करना है, तो इसका answer क्या होगा? What is the answer? This is going to be very easy because we already know that kappa is equal to G times G star, where G is conductance and G star is cell constant. Okay, cell constant. G star is cell constant and this is conductance and this is conductivity. Okay, so conductivity value is given 0.146 times 10 raised to minus 3. Conductance value is inverse of resistance, that is 1 upon 1500. What is the value of G star? बस इसको multiply कर दो, आंसर आ जाएगा. Okay, Ramkrishna Rao. So if you multiply this, the answer would be somewhere about how much you have obtained, 0.21 N. Yep, the answer would be 0.219. What will be the unit for cell constant? Ramkrishna Rao. What will be the unit for it? Is length upon area, so it will be centimeter inverse. 0.219 centimeter inverse will be the answer to this question. Okay, it's very easy problem, very straightforward question. However, इतने straightforward examination में आ गया, then it's very nice. But at least for now, आप start कर रहे हैं solve करना. So start with easy problems. You can move on to difficult ones little later. Okay. Next question is this. In a conductivity cell, two platinum electrodes area 10 centimeter square are fixed at 1.5 and they are 1.5 centimeter apart. The cell contains 0.05 normal solution of a salt. If the two electrodes are just dipped half, I have not dipped it completely. See, you can see that the area is 10 centimeter square. I am not dipping it completely. I am dipping it only to half into the solution, which generates a resistance of 500 ohm. Then what is the equivalent conductance of the salt solution? Okay, what is the equivalent conductance of the salt solution? You have to calculate the equivalent conductance. कैसे हम इसको calculate करेंगे? What will be? How do we calculate the equivalent conductance? You have been given so many information. So how do we do this? Since it is immersed half, the area will be equal to 5 centimeter square. It is immersed only half. The total area is 10. So the effective area that we will be taking for our calculation is 5 centimeter square. Length will be equal to 1.5 centimeter. Okay, resistance is 500, so conductance निकाल लेंगे हम. So G is equal to kappa A upon L. Okay, I need to calculate kappa. Because I need to calculate equivalent conductance later on. So G is given as 1 upon 500. Kappa is to be calculated. A is 5 and this is 1.5. Okay, this is 1.5. From here I will calculate kappa. Kappa value I'll just write it as this will turn out to be so I'll write this thing as kappa is equal to 3 upon 5000 something. Okay, kappa will be equal to 3 upon 5000 and this will be Siemens centimeter inverse. Now I need to calculate equivalent conductance. Equivalent conductance is kappa times 1000 upon whatever is the normality. Equivalent conductance is this. So kappa value is 3 upon 5000 and this is 1000 upon 0.05. So this gets cancelled. I would have, this is 100, so this is 25, 4, this is 12 Siemens centimeter inverse equivalent inverse. It will be 12. Okay, the right answer will be this. Is that understood? The right answer will be this. So with this we end today's session. Okay, we end today's session. I hope I have calculated correctly. This is 10, so 3 and this will be 3 by 5000. Yeah, that relationship between conductance and solubility product and other things that we attend them on a regular basis. Okay, so with this I take leave. Try to solve the last question once again क्योंकि वो थोड़ा सा difficult था, तो इसको फिर से solve कीजिएगा. Okay, so with this I take leave and I hope you have a lovely time ahead. Bye bye guys.